We're trying to run, in my opinion, a little bit too fast right now with the steps that we do on the technology. When you run too fast, your probability of falling on your face is way too high. So we need to be careful. It takes about 2 years to 3 years to actually deploy and stabilize a technology in infrastructure or in compute or GPUs. And we need to make sure that we're giving the time between phases to mature and not running to the next one, the next one, the next one in a constant loop and never stabilizing our infrastructure. It creates a lot of stress on the infrastructure because when you create a fast cycle of technology, the infrastructure cannot catch up that quickly because the cycles are different than the technology cycles. And that's a mistake that some people do. They say, okay, I'm always going to buy just the latest and greatest. It means that every 12 months your equipment is actually obsolete. And that's something that's not sustainable. Hi, my name is Yuval Bachar, and I'm the CEO of ECL. And I'm very happy to be part of the Data Center Go to Market podcast.
Hi, it's Joshua Feinberg, host of the Data Center Go-to-Market podcast, and I'm thrilled to be welcoming a very special guest today. Joining me is Yuval Bachar, who is founder and CEO of ECL in Mountain View, California. Yuval, welcome to the podcast.
Oh, thank you for having me.
Oh, it's my pleasure. I'm really super curious to have our viewers learn a little bit more about your background and what led you to want to start ECL.
Yeah, so prior to ECL, I was the principal architect at Microsoft, and I was the head of the data centers of LinkedIn and built some network gear for Facebook. So I ran across multiple very large companies who built very large data centers and got exposed to a combination of hyperscaler build-outs as well as build-outs which are happening into co-location. And prior to my tenure in Meta, I was actually working for Cisco for a very long time, building equipment, mostly optical equipment for the core routing of the internet. Started my career, and I'm completely dating myself over here, in a company called DEC, Digital Equipment Corporation. I was part of the alpha team over there, that a company that does not exist anymore, and you need to be at a certain age to know about it.
I think we're roughly around that same core Gen X. I was listening to a podcast interview with Steve Ballmer about a week or two ago talking about Dave Cutler and DEC and Alta Vista and everything, and and how it fed into Windows NT. So I'm in that core generational group too. So deep appreciation for the heritage that got us here.
100%. Now, why did I start ECL? So I was working for corporate America for a very long time. And I started ECL for three main reasons. The first main reason was for a very long time, I was on my mind that we can build a sustainable data center. And when I was operating in the data centers group, which were data centers for large scale deployments, we're always in a position that we have a working solution. We do not need to disturb the working solution, and sustainability is an important aspect, but it's a byproduct. And I decided to actually leave the large companies and say, okay, let's try and solve the problem bottoms up with take a clean slate and basically go and see, okay, what's the best data center sustainable we can do? And as a result, it ended up with the product that we have right now, which is an off-grid hydrogen-based data center, which does not consume water at the data center as well, and operate with zero emission. That was the first motivator. Second motivator was to build high-end data centers for everybody else, because the hyperscalers were able to build high-end data centers for a long time, and everybody else had to compromise on the traditional colocations, which were relatively low grade from a performance perspective, from an efficiency perspective. And I want to bring the capabilities of really high-end data centers into colocation style solution. And lastly, define new ways of actually solving the cooling problem. It was pre-AI, so I was a little bit ahead of the market at that point. I was trying to push to 50 to 75 kW. People were telling me there's no way somebody will need this. Now 50 to 75K is not really sufficient to what we're actually building. So those are the three main motivators to leave the large companies and build a small one. We're fortunate enough to be in exact timing to deliver the product that AI needs right now. And where we believe that we have the right path to actually create a large-scale data centers which are fully sustainable with zero issues, zero emission, and zero water. And that's, I think, the key to our success right now is being able to deliver very quickly very good technology of data centers and create the opening path for sustainable data centers.
What's really interesting too is when you're talking about the density requirements, where as recently as 3, 4, 5 years ago, people were kind of waving it off and saying, there's no way people would need that. Are you getting to the point now where a core part of your conversations are coming from people that have faced grid availability as well, where they just simply can't build in certain areas? Yeah.
100%. Most of our customers right now are facing with the 3 to 4 years wait time for grid, if there will be a grid. In some cases, you'll be considered 3 to 4 years. Doesn't mean you're going to get a power in 3 to 4 years. And the demand for the power and the AI deployments is now. So whoever tells us we can solve the problem in 2030, 2035 doesn't help us right now, doesn't solve the problem. And that leads to a lot of customer engagements because we can run without the grid connection. But the important thing is we can run without the grid connection without compromising availability. And that's the key for a lot of our customers, saying we're willing to go off grid, but your architecture needs to show us how you don't compromise our availability. And we have a solution which allow very high level of availability on the data center, even though we're not connected to the grid.
So with ECL, are you 100% focused on modular, or are you also supplying hydrogen, applying alternate power for more traditional colo and hyperscale facilities?
So we mostly focus on the whole package, the whole solution. Our product is a data center as a service. We can do it in colocations, we can do it in other places, but we're not selling our energy solution by itself. And the main reason for that is that our energy solution is actually tailored into the data center architecture. We modified the architecture of the data center completely by eliminating the diesel generators and the UPS system. So we have a new architecture of power. So just adding the hydrogen as a generator to an existing site is much more complicated than actually revamping the whole thing. Plus, we are running hydrogen as a primary load carrying platform. Most of the data centers that we're right now talking to about leveraging our technology or looking to actually use it as backup. And as backup, there are other challenges with how you deal with hydrogen and how do you deal with hydrogen storage, etc. So I would summarize, yes, we are building the data center as a whole, and we are a bit shying away from just selling the technology for the power itself. But for the right partnership, we will actually share our technology, because one of our goals is actually to show the world that everybody can build sustainable data center. Everybody who has access to hydrogen can actually run with hydrogen in data centers. And that's the key. And for that, we're actually going to license it out. We're going to sell it out. We'll do all the models that operate to create as much as possible deployment of hydrogen-based data centers.
So does your modular approach have the same kind of thinking as traditional modular data centers, where you're physically building a container with
no, not at all.
No. Okay.
Not at all. So we're building modular data centers, which means we're building a set of blocks which are isolated. Our block is ranging between 1.5 megawatts up to 10 megawatts right now, and in the future we're probably going to 20 megawatts. And the block is actually a structure that is actually shielded by the power generation system and the cooling system, which are embedded into that block. And when we build large-scale data centers, we just put them next to each other. So we build a structure and we put another structure next to it. As a result, we can actually build really, really fast, because we can run parallel buildings and not as one single building. So that's the reason why we can accelerate the processes and create a repeatable, low-risk build-out, which is still concrete, still the same building as you see in traditional data centers, but it's actually isolated from a power, cooling, fire suppression management on a block-by-block basis, which our customers love, by the way, because it gives them a much smaller blast radius from a failure domain.
But from like disaster recovery business
Exactly.
continuity. Yeah. Yuval, you've been in this industry for quite some time now. Most people would probably consider you a veteran of the data center industry. When you come across young people that are in their teens, early 20s, like high school, college age, and they approach you for advice about career options in data centers and digital infrastructure, especially if they're not all that technical, they're thinking maybe like account manager, sales, product management, channel partnerships.
Yeah.
What advice would you give to someone's son or daughter over coffee or lunch who's looking to get some career advice?
Yeah, so if you want to be on the engineering side, go to the heavy engineering side, because the soft engineering side will probably disappear in the next 5 years, at least for junior people. And so if you're going into college right now, you're going to come out of college at 2028, 2029. There's a good chance you won't find a job because AI will write much better than you. If you're going to the other support mechanisms, I think supply chain and project management are going to be key for success for any project. Supply chain right now, supply chain and power availability are the bottlenecks to build data centers. And whoever is going to be an expert on that will have job for a very long time. And because we're growing so quickly, this is a job that actually you can grow into. You don't have to start as the expert. So I would say if you're looking for the soft side of things, supply chain, project management, program management, clearly sales, even though sales today, we're at a point that this is a seller's market. So there's much lower availability of sales of a space than the demand. The demand is about 3x to 4x the available space. So selling is relatively easy. So you might see a reduction in the number of salespeople for the next 5-6 years because the competition is very, very limited. So I would say focus more on running the projects and running the data center. If you're interested in coming into the data center, there are a lot of roles in the data centers which are operating the data centers, running with the energy side, and running on the cooling systems and operating at high intensity mission critical roles. Some people like it because it's a lot of action all the time. That's also a place I would recommend to people to actually go, and that is actually a role you don't have to go to college for. So if you don't feel like you want to go to college, you can still get training and become a very good expert on data center operations and run data centers. We have an example over here, an intern that converted into a data center operator, and he's doing an amazing job. And he's still in school, so he's still studying.
So this is the whole idea of getting to teens before they even decide about college, before they take SAT prep classes, before the parents take on a second mortgage to send them to a school. They may realize that they want to go directly from high school into something that's a little bit more trades.
And I don't want to encourage people not to go to college. College is important, but I think if not everybody wants to go to college, and here there's an opportunity to actually be very successful with about 6 months to a year of training, and then it's a good job. It's good jobs, and we want the young generation to come in before college or after college. It doesn't really matter. We want them to come in because we have too many old people who look like me running the data centers right now. We need more younger people, which actually take the torch and move it forward. And this generation, the younger generation, is actually much more sensitive to the sustainability aspect. So it's actually very, very important to get them in and get to the point that they actually understand that they can influence their future. And that's a direct influence to their future because data center is becoming so dominant in the power consumption of the world. So the future of our children and grandchildren is actually relying on the fact that we will actually do it right.
Yeah, no, that makes a lot of sense. Yuval, what about someone who's more mid-career? Maybe it's someone that you worked with 10 or more years ago at Meta. You haven't seen them for a while. You bump into them at a conference or the airport. You used to be good friends, and you sense that they're a little bit burned out. They're thinking about a career pivot or a reset. What would you talk about that with him or her over coffee or lunch?
Yeah, I think I have a unique view of the world from coming from many years from corporate America into a startup environment. So that's a very, very amazing transition that you can do. Usually, most people do it at a very young age, and then it's easier for them to actually handle the stress and handle the other things. But on the other side, a lot of older people are shying away from going into startups because it's a little bit more stressful and there's a higher risk. but the reward that you get, not just financially, also the reward to actually be able to control your own destiny, have an impact on the company, which you usually cannot have in large companies, is incredible. And it re-energizes you. It gives you a lot of room for innovation, room for doing things which are out of the box. I always like to quote a statement that was very common at Meta, and that's, "What would you do if you're not afraid?" And that's we do it over here all the time, and that's the message to our team. Go take risk, do what you're afraid of, you thought you're afraid of, and it's okay to fail. Not too often, but it's okay to fail.
Yeah, it's a really interesting mindset, especially coming from the standpoint of yourself that spent nearly all of your career working for big enterprises.
Yeah.
Imagine when you got to Meta, they were a little bit smaller than they are now. But,
oh yeah, much smaller.
But yeah, for sure. Your first foray into entrepreneurship. So really, really interesting to get that perspective. Yuval, when you look at what's going on in the industry in the US and even globally, what do you think is the biggest mistake or oversight that people make when they're thinking about alternate energy, when they're thinking about hydrogen fuel cells and data center construction?
I think so philosophically, and I'm talking philosophically in general, how I look at business is to have a justification to live without government control, support, and financing. And a lot of the solutions out there for sustainable data centers are heavily relying on subsidies from the government, or encouragement from the government, or driving money into investment into capex or in the government. And they overlook the perspective that they need to actually be viable by themselves. And that's something that I think a mistake a lot of people do, and we experienced that in the US, right? So there was a very strong push for green hydrogen. The new administration came in and said, you know what, green hydrogen is not a priority for us. And now whoever relied on the fact that you're going to get subsidized green hydrogen right now is having a major problem on their business, including the people who try to operate data centers with green hydrogen. We choose a path which is a blended environment, green, blue, that will give us the ability to create data centers irrespective of subsidies from the government. And it's actually helping us extremely well when we go to discussions with customers. The second thing I think that people do is we're trying to run, in my opinion, a little bit too fast right now with the steps that we do on the technology. When you run too fast, your probability of falling on your face is way too high. So we need to be careful. It takes about 2 years to 3 years to actually deploy and stabilize a technology in infrastructure or in compute or GPUs. And we need to make sure that we're giving the time between phases to mature and not running to the next one in a constant loop and never stabilizing our infrastructure. It creates a lot of stress on the infrastructure, because when you create a fast cycle of technology, the infrastructure cannot catch up that quickly, because their cycles are different than the technology's cycles. And that's a mistake that some people do. They say, okay, I'm always going to buy just the latest and greatest. It means that every 12 months your equipment is actually obsolete. And that's something that's not sustainable.
That brings up a really interesting question too on cycles and timelines and managing expectations. When you speak with people that are new to this, and given that you're really creating a new category, what do you tell people in terms of planning timelines for a project that ECL would build compared to a traditional data center build?
Yeah, so traditional data center build right now is about 3 years, 3 to 4 years from PO spec, 3 years. We're building off grid, so it's shortened the cycle. We're building modular, shortening the cycle. We control the supply chain with a very highly vertically supply chain that we have. So we turn around our data center in 9 months. So from the moment we get a PO and spec, we deliver up to 150 right now megawatts to the customer after 9 months, rack ready. So it means everything is set. It's not a white space. It's actually including the cooling system and everything set up. Now, why is that important, and why is that something that people need to strive for? Like we talked before, NVIDIA is turning around their equipment every year. So if you try to spec right now, a data center will be delivered to you in 3 or 4 years, you're guessing basically. You have no idea what you're going to need, because the cycle is so quick on the technology. In the past, we used to have a relatively stable cycle So we could have done projections of 3 years and do planning 3 years out. Now with the 9-month cycle on the technology and about 9 to 12 with the technology that we have, you can track. So your planning cycle suddenly become a year instead of 3 years. You can be much more accurate on your planning cycle, and you can actually require the right requirements in the data center and not overshoot or undershoot. I can tell you from the days that I was at LinkedIn, we were trying to actually predict 3 years out, but to be honest, it was mostly a guess. We didn't really know exactly what we were going to need, so we're actually going to oversubscribe. And you see it even today. Microsoft is operating the same way, 3 to 4 years projection, and that's why you see them sometimes decommit projects and recommit projects, because the project that they committed to 4 years ago suddenly are either out of scope or under scoped. So that's why you see the transition. It's a natural transition, happen all the time with hyperscalers. But when you go to a shorter cycle of build of 9 to 12 months, you don't need to do that anymore. Your cycle to get tech within the cycle to get the data center are completely in line.
Yeah, it's hard to forecast sometimes on the application side. If I think about
100%.
10 or 12 years ago, no one thought LinkedIn was going to become YouTube. No one thought they were going to be all of a sudden hosting a ton of video, and all of this that's got bandwidth implications, storage implications, power implications. And then Gen AI becomes really big 2, 3, 4 years ago and ramps up all the compute and power bandwidth needs.
Yep, 100%. Nobody predicted that will happen. And like I said, when we talked before, when we told our potential customers we're going to do 50 to 75 kW per rack, they said exactly what you said. There is no way we're going to need this. It's like maybe in 10 years. And now they basically say, oh, just 75, that's what you could give us. Where's the 150? Where's the 225? Where's the 350? And where's the 600 that Jensen is talking about?
The Data Center Go-to-Market podcast is sponsored by DCSMI, elevating the role of sales, marketing, and go-to-market GTM professionals in the growth of the data center industry. To stay informed about upcoming episodes, make sure that you subscribe to the Data Center Sales and Marketing newsletter on the DCSMI website that can be found at www.dcsmi.com. Again, that URL is www.dcsmi.com.
Are most people that you're talking to that are planning a little bit out with the right mindset just thinking Gen AI, or are they also thinking EVs? Are they thinking smart cities? Are they thinking a lot of IoT?
Right now, the massive demand in the market is for AI factories. In about 2 to 3 years, it's probably going to be balancing out into the inference part of the things, and that's where EVs and smart cities are coming into play. But right now, it's all about training and training a lot of models very, very fast. That requires a lot of power and a lot of space.
Where do you see as the strongest use cases today? What industries are most interested? What business models? What kinds of stakeholders in these organizations are typically your internal champions?
For AI, you're talking about?
No, for what ECL does.
Oh, so I think we usually initially started with the sustainable team in every one of our customers, potential customers. Now the customers are looking for the time to delivery. So we actually morphed from actually having a first entry to the company at the sustainability is we're going now to the planning teams, because the planning teams are struggling right now to be able to get this. And we bring the sustainability as the add-on. So they basically go and sell it inside. Hey, yeah, this is also sustainable. But in the past, it had to be sustainable before they even talk to us. So that changed for us from their perspective. The second thing is actually the AI matching. A lot of the data centers out there are not adequate for running the AI. They need to go through major retrofits to be able to run properly at the high density with the direct-to-chip liquid cooling, with water cooling, and the density per square foot. And as a result, you get to the point that the people who build the data centers right now are struggling. And it's a different group of people now who are saying, okay, we're looking for the high-end data centers. Who can actually give us the high-end data centers? And there's probably a handful of companies out there that can actually build those data centers, no more than that.
Because of the nature of how fast you can build, it gives you a lot more agility and flexibility. Are people talking to you about edge applications for this, or do you still see more traditional?
They do, and in Edge we have an interesting position because in Edge we can leverage the grid. So our architecture does not require only hydrogen. We can actually be grid and hydrogen combined, and we have our software which balance between the grid and the hydrogen generation. So definitely sites between 5 and 15 megawatts, which in the past were pretty large. Now these have become edge sites. It's not a megawatt anymore. There's very small 1 megawatt edge sites for AI applications. So definitely, yes, because we build modular, for us, instead of putting 100 modules, we put 5. It's okay. It's completely fine by us, and we can put a lot of those 5s everywhere. And with hydrogen, when we do smaller sites, edge sites, we actually get liquid hydrogen delivered to us because we don't have a pipeline for hydrogen everywhere. And that's another message that the industry should actually push. We need hydrogen distribution systems. Europe is pushing really hard right now for a full pipeline coverage. US is a little bit slower on that, but that is key. If we can actually deliver natural gas to every home, we can deliver hydrogen to every region. We're not saying to every home, but every area should have an entry of hydrogen. That will be a game changer. That combined with, if we find other sources of hydrogen, like the white hydrogen, which is being explored right now, it's a naturally occurring hydrogen, that will be a complete game changer in how we actually generate energy.
So you mentioned a few moments ago that your initial foot in the door curiosity was with the ESG folks, and then it's moved more to the construction and development folks. Are there been any non-intuitive kind of surprises with stakeholders who've been really interested in this, either internally or externally? Like, are you getting much interest from real estate folks? Are you getting much interested from developers, investors, anything like that? Or does it tend to be more the internal leading the
so it's an interesting, for me, it's an interesting experience because I was engineering all my life. I worked for large companies, built data centers. I never actually experienced who is actually pushing it from the outside. And we see a tremendous level of interest for real estate investors, both small ones, banks, and PE investors, which understand that with today's demand, there's an opportunity to a highly profitable real estate investment. So you see them driving the market in a lot of cases. They're driving the money to the right places where they need. Internally, you're dealing with a completely different group of people. You're dealing with people which are very, very focused on the brick and mortar and being able to build fast and very heavily embedded into the construction portion. And they bring the lawyers and the finance people with them. Unfortunately, and it's an unfortunate situation, the ESG people have been shifted to the side a little bit, because the priority is to get fast data centers in place for AI to be competitive. The window for some of those companies will close in 4 years. So if they don't establish themselves very, very strong in that market in the next 4 years, there's a good chance they will not be able to recover.
Are you seeing many conversations with site planners and designers, architects, or is that less critical because of the role that ECL takes?
I think it's much less critical. We define a single block with them and just repeat it afterwards. We make our sites look very nice because when you do modules, you can actually beautify them. It's not like one big concrete building. So we do have architects, and that's part of our value proposition that we give when we come to the communities, for example. This is not going to look like an ugly data center like you have across the street from you right now. It's going to look much nicer. And as a result, architects are more creative to create things which are more appealing for people to see. And the design teams that we're working with are actually love the aspect that they design small blocks, because small blocks is much easier to design and just stick them together, and you can do shapes and you can do all kind of other things when you do that way. So they love that concept. They design a small block and then just repeat it, and then gives them the freedom to how to repeat it, how to distribute the blocks, how to actually create the distribution around the blocks for power and hydrogen in our case.
Is hydrogen, the way you're designing this, hydrogen's always the primary, and then it's up to the client with the project to figure out what their backup is going to be?
No, what we do is our architecture, when we eliminated the diesel generators and the UPSs, we had to go to a new power architecture. So our architecture is actually multi-active sources. So we push 4 active sources into the data center, which are active all the time. There's nothing sitting in standby. And as a result, we can actually bounce between the sources of the energy on the fly and we create redundancy like that and high availability. For full AI workloads, we need a lot of storage capacity because the AI workloads are actually extremely erratic. They change very rapidly, and they can be plus or minus 30% in demand. Most of the equipment out there does not know how to handle it. So the new architecture that we have enables us to do that without using any exotic technology and be able to maintain that. So our backup system is actually embedded into the power generation. It's part of the power generation. It feeds and supports the power generation 24/7. It's not sitting idle.
So it's really a new category of equipment?
100%. The architecture of the power is completely new. The moment you eliminated the UPS and the diesel generators, your way of looking at the power and the availability of power is completely different.
So you mentioned before the challenge of being able to plan ahead. I'm curious, from where you sit as the founder of ECL, what do you think may change in the next 2, 3, 4 years about building a company like ECL? What do you anticipate may change about even your daily routine?
So you're talking about ECL, or you're talking about in general, if somebody wants to start another company like that?
A little bit of both.
So about ECL, I think we're transitioning. So we are focusing on the current generation of the engineering and transitioning to the new generation of engineering. I'm an unusual CEO. I'm a technical CEO, so I'm actually involved in the engineering work as well. I'm not just doing the overhead work. I think that's going to be required for anybody who's going to do that. The focus is actually moving right now more into operations, supply chain, and a lot of things that you need to do to be successful once you have the first product in hand. The first product is running for us in Mountain View for 1.5 years now, so we're highly confident about it, and we're just shifting the focus into supply chain, customer acquisition, and operations. If you start a new company right now, you need to shoot very, very high. So whoever thinks about starting a new company or spinning out of a data center company and creating a high-end version of that, you need to shoot very, very high, because the changes are happening so quickly. If you start now, you're going to deliver something in 24 months if you do the engineering work properly. And then in 24 months, the data centers are going to look very, very different. So the opportunity for who has started is huge. And a lot of people ask me, so how do you actually quantify your opportunity? For us, it's very easy. We do not need to take market share from our competitors. We just tap into the growth, and we tap in a single-digit percentage of the growth, and we'll be very, very successful by doing that. So that's a very unique position for a startup, because most startups actually are trying to displace an existing product or do something which is a little bit better than the existing product. We are in a world where we don't compete. We just, as much as we can deliver, we'll win. It's a different mindset from a perspective of a data center delivery. And the second thing, we can think creatively on business models. Traditional business models don't apply anymore. So we're actually offering a lot of variety of business models to engage with our customers, which were not available before. And the one interesting thing is that we work on a 9-month cycle, so we allow them to actually change the business engagement model every 9 months, which usually you don't see. Usually those engagement models are 10, 15 years. We allow them to actually rediscuss the engagement model every 9 to 10 months, because their demands is changing and their requirements are changing, and they prefer to do it that way. So it gives us another layer of innovation around the business engagement models, not just on the engineering.
So with the whole modular approach, it's not surprising how vertically integrated you are with the supply chain, and that you've had to create some of your own equipment to rethink how the energy is supplied. Are there other parts of the ecosystem where you're getting involved where traditionally people wouldn't think a company with ECL, like, for example, is there still a need for traditional commissioning, or is it a different kind of process?
It's a much more repeatable process, because you do one at a time and you can parallelize it. But the one interesting thing that we do, which is unique again, we run an AI agent which is running the data center. People are not running the data center. It's run by an AI agent, and people come in only if they need to actually touch physical things. And even that will probably go away in a few years when we're going to have robotics stable enough to do that. So that gives us an opportunity to do all kind of special things, especially around commissioning and parallel commissioning and interaction between the agents, which actually were running different blocks, and a lot of very, very interesting aspects of development and new innovation. We built a management system to run the data center because we couldn't find one which was good enough to what we needed in our architecture. And that's another aspect. There's a lot of data center companies don't deal with this. They just go buy DCIM from some external company. We decided to take it and do it because we want to optimize every aspect. And talking about vertically integrated, we are vertically integrated from the lowest level of the software or how to move things around all the way to the big power generation units.
Yeah, so you've had to build essentially your own platform.
100%, yeah.
Yeah, it definitely gives you a competitive advantage, and it gives the clients, the operators, the confidence to know that everything will work together without any finger pointing or blame
100%.
or shortfalls. Do you have any favorite tools? Speaking of AI and productivity tools and software, do you have any favorites that you use to do your job on a regular basis, kind of those must-have tools that if an IT person or a finance person said, hey, why are we doing this? You'd say, no, it's absolutely essential for not only me, but for our team.
Yeah, so I think the evolution of the AI agents that help us is a variety of them. It starts with the ChatGPT and Grok and others, which actually help you to write documents faster, develop platforms better, faster, develop procedures faster and cleaner. It starts at that level. And beyond that level, what's going on is that we can actually start using AI agents to start doing functions in the organization. Like, for example, we do not have HR in our organization. We have an AI agent which is running HR. We start to run more and more of our simulation by AI agents, where we only supervise what they're doing. So there's a lot of opportunities to actually start moving functions into AI models. I think for now, the ones which are actually the most helpful for us are the most basic one, are like ChatGPT and Grok. Some of the graphics AI tools as well are helping us when we actually present outside. Writing documents right now and operating in a world of PR and a world of even legal is much, much easier and makes our life much faster and actually more cost effective, to be honest.
So is this a lot of what folks that do things similar to what I do in the marketing and sales enablement world are talking a lot about agentic AI? Is this similar, but just on the building management?
It is. Yeah.
So the agents talk to agents and you're building teams of agents.
Exactly. So the moment the agent starts to actually manage other agents, that's a game changer. We're not there yet for ECL, but there are some applications which are doing that already. We'll get there because when we run large sites, we'll have agents running every block, and then we have a super agent who will actually run all the agents, and then we'll start actually giving instructions to the agents to actually run their localized robotics that will help them actually do the maintenance and preventive deployment of equipment, etc. That will be a 3-tier or 4-tier of agents which are actually going to run each other. So that's becoming very interesting, scary on one side, but very interesting on the other side.
So that sounds like a really interesting area of concentration for someone that's entering college 100%. In the next 6, 12, 18 months, is to get out of school and become an expert on building and troubleshooting and integrating.
100%. 100%. The agents will dominate the most of the standard non-innovative roles. Innovation from agents is probably going to take another decade or so also. But the roles that you do on a day-by-day basis, agents run 24/7, don't complain, don't need PTO, don't need to buy them lunch, and they're actually working in a very consistent way. It doesn't matter if they woke up after 3 hours of sleep or 12 hours of sleep, they work the same thing. So there's a huge advantage if you try to create mission-critical solutions which are consistent and repeatable. Agents work really, really well in that environment.
As you get deeper into the supply chain as well, you mentioned the challenges of getting more hydrogen distribution network built out in the US. That seemed like another area where you could potentially have IoT and autonomous and
100%.
and agents and better understanding what's going on more than just the driver's GPS on their phone.
Yeah, I think the hydrogen economy is in a place where it's emerging, and when something emerges as an economy, there's an opportunity to actually do things better than what we did before in other communities or other economies. So we need to learn what happened, for example, with natural gas distribution. How do we do it better with hydrogen? The commercial aspect of it is becoming very, very interesting. How do you actually get hydrogen properly? And research as well. Research right now, the hydrogen research is very, very infant state right now. People generating energy the same way for the last 15, 20 years. It's time for new innovation on how we actually create hydrogen until we find the one which is naturally occurring on the ground.
I always ask people too, as well, when we talk about these alternate energy sources, why do you think the incumbents, why do you think the people that would have had the ability to see this coming and plan for it 5-10 years ago, why did they not jump all over this?
Oh, because this market is very, very conservative. So they basically have something working and working well that they don't touch anything until there's a threat, right? So there's the book, The Innovator's Dilemma, you probably read it, and basically says if you're complacent, somebody will displace you. And what they're doing right now, the original producers of hydrogen and producers of energy in general are trying to catch up. And you can see it on country level, state level, and in the Middle East suddenly, which is the source of most of the oil, they start talking about hydrogen suddenly. It's okay, why are they talking about hydrogen? They have so much oil over there because they see the future, they see where it's going. So they're investing in it. And the same thing for the companies who deliver over here. They deliver gas and deliver a lot of other materials, and hydrogen is part of it. Now they're scaling up their hydrogen when the off-taker is coming, and we are the off-taker. So they were waiting for a very long time. Who's my off-taker? Now we represented them an off-taker that will take the hydrogen and build energy for data centers from it.
It's really fascinating. Yuval, I really appreciate you taking the time to chat with me today and help our audience better understand this emerging category of how data centers are going to be built going forward with hydrogen fuel cells baked into the design and the entire supply chain. It's been super fascinating.
Thank you very much for having me. I really enjoyed the discussion.
Yuval, if someone wants to reach out to you, learn more about what you're working on with ECL, is LinkedIn a good place to start?
Yes, ECL LinkedIn, or directly on my LinkedIn, or through our website. You can actually reach out to us and we'll reach back right away with any help, technology sharing, and clearly data center space.
That's terrific. We'll make sure to include links to those with the blog posts and with the show notes as well, so people can reach out to learn more. It's been terrific. Today I've been speaking with Yuval Bachar, who is the founder and CEO of ECL based in Mountain View, California. Yuval, thanks so much for joining me today.
Thank you.
The Data Center Go-to-Market podcast is sponsored by DCSMI, elevating the role of sales, marketing, and go-to-market GTM professionals in the growth of the data center industry. To stay informed about upcoming episodes, make sure that you subscribe to the Data Center Sales and Marketing newsletter on the DCSMI website that can be found at www.dcsmi.com. Again, that URL is www.dcsmi.com.